What? There's no way. That's not a word.
Bro, yes it is. What do you mean?
No shot.
Chapter House?
I don't know about that.
Bro, it's in Dune. Frank Herbert?
I don't know. Let's check the dictionary. Let's look it up.
I don't have a dictionary. What are you talking about? Bro,
Okay.
look it up.
You know what? I'll go with it. Let me score this. This is tough. 3, 7, and then what's the?
That's you gotta double that.
Got to double that.
So do I get points for like just the ones I put down, or do I get points for those two?
I don't know. This is tough.
So tedious.
I'll just give you 5 and we'll move on.
Bro, 5? I got a lot more than that.
No, 5 seems fair.
That's at least like 15.
Okay. Or not, that kind of long.
14, I think. Bro, why is this so hard?
Yeah, this is too much.
Can we play Monopoly?
Yeah.
You gonna play something?
I don't know, man. This is tough. I can't think of any words.
It's been like 10 minutes. There's gotta be one word on the board you can play.
I see little words, but I want a big score.
We can see it's player 1's turn as its score is bolded. Player 1 now plays their word. He now presses the check button to validate and get the score back. The score is valid. The word is valid and score of 13 points. So he now presses the back button. Player 1, would you like to play this word? He does, so he presses the submit, and that submits the word. And as you can see, player 1's score is changed.
Now this player will demonstrate the hint functionality. They'll first input the tiles on their rack using the touchscreen. Then, once all their tiles are entered, they can press the hint button. We can see that then the top 5 scoring words are returned to the player, with the word, the score, and then their start and end location. Now the player can play the word.
You can now see what happens if a player tries to play an invalid word. So in this case, they play BELF. And after checking, they get feedback indicating the word is invalid. So I developed the computer vision aspect of this project. So whenever a player tries to check a word or submit a word, the main Raspberry Pi will take an image of the board and run it through some pre-processing, which includes converting it to black and white, applying Gaussian blur, then followed by erosion and dilation to both remove some of the noise and also really highlight the contours of the characters. After this, we run it through a contour recognition algorithm using CB2, and we then filter out these contours, which are unlikely to be actual characters, based off of area of the contours as well as the size and shape of them. We then use the locations of these contours to feed in each individual character into the character recognition, which is just a nearest neighbor model. We have a small character database, a couple photos of each character, and apply k-nearest neighbors to match each image with a character. And then we use special characters on each corner of the board to map these locations to their corresponding locations on the board. And so at the end of this, we have a 2D list where each character is in its corresponding location on the board.
I worked on the hint generation algorithm for this project. We based it off a paper that was actually written by two CMU professors back in 1988 as to how to find the best scoring word based off the state of the board and your tile rack. So the first thing to talk about here are anchor squares. So with our anchor squares, we're just going to talk about horizontal direction. It could be generalized to vertical. Horizontal anchor squares are any squares that are blank to the left of an already filled tile. So what we do is we start at these squares. We're going to use our algorithm, backtrack left, looking in our directed acyclic word graph to see if they're valid words. The directed acyclic word graph, it has a root and it has edges for all the letters that can be after that suffix, after each node, after suffix. It is different from a tree because it holds suffixes are in similar nodes and similar edges. Next, we're going to see that every word horizontally that you make also has to form a word vertically. So we make something called cross checks, which is a set of letters that if you're going to play a horizontal word, a set of letters that can also be played vertical. So here, an example, H would not work here, but O would. After we talk about backtracking left, we're going to go right now, see if those are valid words. Once we get our set of valid words, what we do is we have a dictionary of the word, the score, and the starting and ending location of the word. That is then sorted by score and returned to the players for their playing.
Now I'm going to talk about how our devices are able to wirelessly communicate with each other. So what we decided to use was a form of communication called MQTT. And so basically what we have is our main device is subscribed to a topic called send. So whenever one of our RPi zeros want to send a message, they tag it with the device topic send, and then the main device will receive it. And similarly, our RPi zeros are subscribed to a topic called receive. So whenever the main device wants to send out data to the RPi zeros, they tag it with the topic receive. The MQTT system has a lot of benefits, but this subscribee model was what initially drew us to it. So then as well, in order to classify our data, we use a format like this, where each data packet that's sent has a little header here that has the device sending ID. So for example, if we were sending out, let's say words that we created from our hint generation, the sending ID would be from the main device, so it would be 0. Then the receiving ID would be whichever player 1 through 4 that we're sending it to. And then the task ID, which for the case of hints is 3, would go into here. And then the actual data, so the words, the scores, and the locations would go into here. This header format made it very simplistic for us because we were able to, instead of distinguishing each individual topic, like having the receive 1, receive 2, receive 3, and receive 4, we just have the one receive, and then when it gets to the device, they compare the receiving ID to their own device ID, and they're able to distinguish whether or not the packet's for them.
Oh, so, okay, it tells me whether the word is valid, and then it gives me the score too, so I'll do this.
Yeah, this is great. I don't know how we ever played without it.
Isn't Scrabbletron awesome?
It's the best.